Welcome to the deep dive. Today, we're plunging into the world of artificial intelligence, AI. It
Right.
feels like it's woven into pretty much everything these days, but the core of it, well, it can still seem a bit mysterious, can it?
Absolutely.
Think of AI as the technology that's giving computers a serious brain upgrade. It lets them do things we used to think only humans could.
Exactly. And if you're looking to really grasp what AI is all about, without getting lost in like a maze of tech speak,
Yeah.
you've come to the right place. We've sifted through a wealth of information, including a really good overview from Google Cloud to bring you the crucial insights.
Okay, so our mission for this deep dive is straightforward. We're going to explore AI in depth, but keep it efficient, focused on what truly matters.
Right.
We'll break down its definition, uncover how it actually works, its magic, explore the different kinds of AI out there, understand how these systems learn.
Demystify neural networks.
Yeah, demystify neural networks and highlight the real-world advantages and applications. Consider this your fast track to really getting the fundamentals of AI. Okay, let's unpack this. What exactly is artificial intelligence at its heart?
Fundamentally, AI is about equipping computers with the ability to perform sophisticated tasks.
Okay.
Things like understanding human language, recognizing images, sifting through massive data sets, even making intelligent recommendations.
Mm.
It's the real powerhouse behind so much of the cutting-edge innovation we're seeing in computing today.
Can you give us a concrete example of AI in action, something we can really, visualize?
Sure, think about optical character recognition, OCR.
Okay.
It uses AI to look at an image containing text, like, say, a photo of a street sign, and extract those letters and words.
Right.
So it's taking unstructured visual data and turning it into organized, structured data,
Yeah.
data that businesses can then analyze for, well, valuable insights.
Ah.
It's not just about convenience either. OCR, powered by AI, is fundamentally changing how businesses can access and leverage information that used to be locked away in physical documents.
Mm.
It turns a bottleneck into a source of value.
So it's definitely more than just clever programming them. There's a whole field dedicated to this.
Precisely. The academic view of AI defines it as a scientific field focused on creating computers and machines that can reason, learn, and act in ways we typically associate with human intelligence. Or, and this is crucial, it involves analyzing data sets far too large and complex for humans to handle effectively on their own.
That sounds like a pretty wide-ranging endeavor. What kind of expertise comes together to create AI? Is it just computer science?
Oh, it's broad, very
Sure.
broad, because AI is a truly interdisciplinary field.
Okay.
It draws heavily from computer science, of course, but also data analytics, statistics, and both hardware and software engineering.
Right.
But you also see strong influences from linguistics, how we understand and process language.
Makes sense.
Neuroscience, as we try to model aspects of the human brain, and even philosophy and psychology, as we grapple with the very nature of intelligence itself.
Wow.
This blend of disciplines isn't just academic talk. It's the very reason AI is capable of such diverse feats, from understanding language nuances to mimicking brain processes.
So for a business leader trying to sort of wrap their head around all this, what's the most practical definition of AI?
Well, for practical business purposes, AI is best understood as a collection of technologies that heavily leverage machine learning and its more advanced form, deep learning.
Machine learning and deep learning.
These are the core tools. They enable things like in-depth data analysis, predicting future trends, automatically categorizing information, understanding human language.
Natural language processing.
Exactly, NLP. Also providing tailored recommendations and intelligently retrieving the data you need exactly when you need it.
Okay, so we have a good sense of what AI aims to achieve. Now let's get into the nuts and bolts. How does AI actually work? What's the underlying mechanism?
The fundamental principle is learning and improving through exposure to vast amounts of data.
Right. Data is key.
Immense amounts.
Yeah.
AI systems are designed to identify patterns and relationships within that data, connections that might be completely invisible to the human eye simply because of the sheer volume involved.
And these patterns don't just magically emerge, right? There's a structured approach involved.
Exactly. That structured approach relies on algorithms.
Algorithms. Okay.
Think of them as sets of rules or step-by-step instructions. They guide the AI in how it analyzes data and makes decisions.
Right.
Now, within the broader field of AI, machine learning is a really critical subset.
Yeah.
Here, those algorithms are specifically trained on data. This could be labeled data, where the answer is already known, or unlabeled data, where the AI has to find the structure itself. And And the goal is always to enable it to make predictions or categorize information accurately.
And then there's deep learning, which you mentioned earlier. How does that fit into this picture? Is it just more complex machine learning?
Deep learning is, well, a more sophisticated area within machine learning, yes. It uses artificial neural networks.
Okay, neural network.
These are complex structures with multiple layers, loosely inspired by how our own brains process information.
Inspired by the brain. Interesting.
Yeah, it's these multi-layered networks that allow AI to tackle really complex tasks, like recognizing images in tricky lighting or translating languages with increasing fluency.
So the layers add depth, hence deep learning.
Precisely. And the key thing to remember is that all of these systems, machine learning, deep learning, they're engineered for continuous learning and adaptation.
Always improving.
Exactly, which is why AI keeps becoming more and more adept at the task that performs. Think of it like a child learning a new skill. The more they practice and get feedback, the better they become.
That analogy helps a lot. Now, when we talk about AI, it often feels like we're discussing different levels of intelligence or maybe different capabilities. The source material outlines a couple of ways to categorize AI. Let's start with how it's categorized by its stage of development.
Right. One way to understand the evolution or potential evolution of AI is by looking at its developmental stages. The first stage is reactive machines.
React machines.
These are the most basic form. They simply react to different inputs based on pre-programmed rules. No memory of past experiences.
So it can't learn.
Correct. They can't learn or improve over time. A prime example is IBM's Deep Blue,
Ah, the chess computer.
the very one.
Yeah.
Beat Garry Kasparov back in '97. Incredibly powerful at calculating moves, but it couldn't learn from previous games or adapt its strategy in a truly meaningful way. It just reacted to the current board state.
So very focused on the present moment, no past lessons learned. What's the next step up from that?
The next stage is limited memory. And this is where basically all the modern AI applications we encounter today reside.
Okay, so this is current AI.
Yes, mostly. These systems can use memory to improve their performance over time. They get trained with new data. Artificial neural networks and various other machine learning models are central to this. Deep learning itself falls under this limited memory umbrella.
Right.
These systems learn patterns from the data they're exposed to and use that learned information to make better predictions or decisions in the future.
Okay, so they can learn and refine their abilities based on new information. That makes sense.
Yeah.
What about the more advanced, almost science fiction sounding categories?
Right. Then we venture into the realm of hypothetical AI. The first of these is theory of mind.
Theory of mind, like understanding thoughts.
Essentially, yes. This would be AI that could truly understand and model the human mind. It would possess decision-making capabilities on par with humans,
Wow.
including the ability to recognize and remember emotions, understand intentions, and react appropriately in complex social situations.
Does this exist yet?
No, this type of AI doesn't exist yet,
Yeah.
but it's a fascinating and very active area of research.
That definitely sounds like something we see in movies. And what's the ultimate, most advanced hypothetical stage?
The final hypothetical stage is self-aware AI.
Self-aware. Conscious.
That's the idea. A machine that is aware of its own existence, has a sense of self, and possesses intellectual and emotional capabilities comparable to, or maybe even surpassing, humans.
Okay, that's a big concept.
It is. And like theory of mind AI, self-aware AI remains purely theoretical at this point, science fiction for now.
Right, so those last two are really about potential future possibilities. What about how we categorize AI based on what it can actually do right now in the present day?
Yes, this is often a more practical and relevant way to think about AI in its current state. Right now, everything we call AI is actually artificial narrow intelligence, or ANI.
ANI, narrow intelligence.
Narrow, exactly. It means it can only perform very specific, limited sets of actions based on its programming and the data it's been trained on.
So it's specialized.
Highly specialized. An AI that's incredibly skilled at classifying objects and images, for instance, won't have any ability to understand human language. It's stuck in its lane.
Okay, examples.
Think about applications like Google Search, predictive analytics used in logistics, or virtual assistants like Siri or Alexa. All incredibly useful, powerful even, within their defined scope, but narrow in their overall capabilities.
So it can excel at one particular task, but can't really generalize or apply that intelligence elsewhere. What are the broader, again, more futuristic possibilities in this categorization based on capability?
Well, the next level up in terms of capability is artificial general intelligence, or AGI.
AGI general.
Right. This would be a machine with the ability to sense, think, and act, just like a human, across a wide range of tasks and cognitive domains. True human-level intelligence.
And this exists.
No, AGI doesn't exist yet. It's a major long-term goal for AI research, a huge challenge.
And beyond AGI.
Then going even further, we have the concept of artificial superintelligence, or ASI.
Superintelligence, smarter than humans.
That's the idea. AI that could function in all ways superior to human intelligence, potentially in every field of endeavor imaginable.
Yeah.
Again, like AGI, this remains firmly in the realm of speculation and science fiction for now.
Okay, that gives us a really clear picture of the different types of AI, both current and potential. Now, you mentioned earlier that AI learns through data. How does this training process actually work? What's involved?
The concept of training data is absolutely key, you're right. Remember how limited memory AI improves with new information?
Yeah.
Machine learning, as a core part of AI, uses algorithms that essentially learn from this data to achieve specific outcomes. And there are three primary methods or models for how this learning happens.
Lay them out for us. What are the main ways we train these AI systems?
Okay, the first is supervised learning.
Supervised, like a teacher.
Exactly. Think of it like learning with a detailed answer key. Here, the algorithm is trained on labeled data.
Labeled data.
Yes, structured data where the correct answer or category is already associated with the input.
Okay.
The goal is for the AI to learn the relationship, the mapping, between the input and the desired output. So if you want to train an AI to recognize pictures of dogs,
Right.
you'd feed it thousands of images that have already been labeled dog. It learns to associate the visual features, floppy ears, tails, fur, with that specific label.
That makes intuitive sense. We're showing it what's right. What happens when we don't have that kind of labeled information? When there's no answer key?
That's where unsupervised learning comes into play.
Unsupervised. No teacher this time.
Right. In this case, the AI is given unlabeled data, unstructured data, without any pre-assigned categories or answers. Its task is to find patterns, structures, and relationships on its own.
So it figures things out itself.
Exactly. The outcome isn't predetermined. This is particularly useful for tasks like pattern matching in huge data sets, maybe discovering hidden groupings within customer data.
Customer segmentation.
Could be, yeah. Or creating descriptive models of complex phenomena. Imagine being given a huge box of mixed Lego bricks and being asked to sort them into piles based on similarity without anyone telling you to sort by color or shape. You'd find the patterns yourself.
So it's more about the AI exploring the data and finding its own insights, discovering structure.
Exactly. And then we have a third major type, reinforcement learning.
Reinforcement, like rewards.
Precisely.
Right.
This is often described as learning by doing or learning through trial and error.
Okay.
You have an agent, which could be a software program or maybe a robot, that learns to perform a task within a specific environment. It does this by receiving feedback.
Feedback.
Yes, in the form of rewards or penalties. It tries different actions. If an action leads to a positive outcome, a reward, it's more likely to repeat that action in the future.
Makes sense.
If it leads to a negative outcome, a penalty, it'll learn to try something different next time. Think of training a self-driving car simulation. It learns to navigate by getting positive feedback for staying in its lane and negative feedback for veering off course or hitting obstacles.
That sounds a lot like how we learn new skills ourselves. Trial and error. The source also briefly mentions something called semi-supervised learning. What's that about?
Yes, semi-supervised learning. It's essentially a hybrid approach, a mix of the first two.
Okay.
It uses a combination of both labeled and unlabeled data for training. This could be really useful in situations where labeling huge amounts of data is expensive or just takes too much time.
So you label some, but not all.
Exactly. By labeling a smaller portion of the data, you give the AI some starting points, some supervision. Then it leverages the patterns it finds in the larger, unlabeled portion to improve its learning. You often get a good balance between cost and model performance this way.
Okay, so those are the fundamental ways AI models learn. Supervised, unsupervised, reinforcement, and a mix. Now let's dive into the architecture that powers many of these systems' artificial neural networks. These sound quite complex.
They can seem intimidating, yeah. But the basic idea is actually inspired by the structure and function of the human brain, like we touched on.
Right, the brain analogy.
An artificial neural network is essentially a system of interconnected artificial neurons. Sometimes they're called perceptrons.
Artificial neurons.
Yeah, they're basically computational units designed to process and analyze data.
So these neurons are constantly communicating and passing information between each other, like signals in the brain?
Precisely. Data is fed into the first layer, the input layer. Each artificial neuron in that layer performs a simple calculation on the incoming data and then passes its result or its decision on to multiple neurons in the next layer,
Okay.
and so on, through one or more hidden layers. Finally, the output layer produces the network's overall result.
Like the final answer.
Yeah, whether it's classifying an image, predicting a stock price, or translating a sentence. Networks with more than 3 layers, input, hidden output, are often called deep neural networks.
Ah, there's that deep again.
Right. That's where deep learning gets its name. Some of the most advanced networks can have hundreds or even thousands of these interconnected layers. Think of it like a really complex decision-making assembly line.
And there are different types of these neural networks, right? Each designed for specific kinds of tasks.
Yes, absolutely. Different architectures for different jobs. Feedforward neural networks, FF, are one of the foundational types.
Feed forward. Sounds simple.
Relatively. In these networks, data flows in one direction only, from input through hidden layers to output, no loops or cycles.
Straight through.
Exactly. Modern versions, often called deep feed-forward networks, simply have multiple hidden layers to learn more complex relationships.
Okay.
They're frequently trained using a technique called backpropagation.
Backpropagation. What's that?
It's essentially a method for fine-tuning the connections between the neurons to minimize errors and improve accuracy over time. Imagine the AI makes a mistake classifying something. Backpropagation is like tracing that error back through the assembly line,
Ah,
identifying which stations, which neurons contributed to the wrong call, and slightly adjusting their decision-making process to improve for next time, is how the network learns from its mistakes.
what about when we're dealing with sequences of data, like the words in a sentence or maybe frames in a video? Feed forward seems like it might struggle there.
You're right, it does. That's where recurrent neural networks, RNN, come into their own,
Recurrent, meaning,
meaning they have loops. Unlike feed-forward networks, RNNs are specifically designed to handle time series data or sequential information. They have a kind of memory.
memory. How?
They can remember information from previous steps in the sequence. This is absolutely crucial for processing natural language.
Ah, because context matters in language.
Precisely. When an RNN is understanding a sentence, it doesn't just process each word in isolation. It remembers the words that came before to understand the context, just like we do when we listen.
Okay.
They're commonly used in applications like speech recognition, language translation, even generating captions for images based on sequences of objects.
And then there's LSTM long short-term memory networks. How do they enhance the capabilities of regular RNNs? Sounds like even better memory.
That's exactly it. LSTM is an advanced type of RNN specifically designed to handle longer sequences and to remember relevant information from further back in the sequence.
Okay.
They have special components called memory cells that allow them to retain important information over many processing steps. This overcomes some limitations of standard RNNs when dealing with long-range dependencies in data, like understanding connections between the beginning and end of a long paragraph.
So they're better for more complex sequences.
Yes, this makes them particularly effective in more complex tasks, like sophisticated speech recognition, understanding the deeper nuances of text, and making predictions based on long-term patterns in data.
We hear a lot about AI being used for image recognition. What kind of neural network architecture is typically employed for that? Is it RNNs?
Not usually RNNs for standard image recognition.
Yeah.
The workhorse there is the convolutional neural network, CNNs.
Second, what's special about them?
They use specialized layers, convolutional layers, and pooling layers that act like feature detectors.
Feature detectors.
Yeah, they scan the image for different visual elements.
Right.
Early layers in the network might detect simple features like edges, lines, and corners.
Right.
Then deeper layers learn to combine these simple features to recognize more complex patterns, shapes, textures, parts of objects, and eventually entire objects like cats, cars, or faces. These extracted features are then combined in standard, fully connected layers at the end to make the final classification or identification. It's a very efficient way to process the spatial structure of visual information.
That sounds like a very logical way to analyze an image piece by piece. And the last type of neural network mentioned is GANs,
Yes.
generative adversarial network.
Yes, Jans. These are fascinating and somewhat different. They actually consist of 2 neural networks trained simultaneously in a competitive setup.
2 networks fighting each other.
Sort of, yeah.
Hmm.
Adversarial. One network, called the generator, tries to create realistic examples like fake images or music.
Oh,
The other network, the discriminator, tries to distinguish between the generator's fake examples and real ones from the training data.
like a detective trying to spot a forgery.
Exactly. And this ongoing competition forces both networks to improve. The generator gets better at creating realistic fakes to fool the discriminator, and the discriminator gets better at spotting the fakes.
So they push each other.
Right. It leads to the generator producing increasingly realistic and sophisticated outputs. GNs have been used to create incredibly realistic artificial images, generate new forms of art, synthesize realistic video footage. It's a really powerful technique for creation.
Wow, the idea of two AI networks essentially competing to become better is kind of mind-blowing. So it's like they're constantly pushing each other to evolve.
It is pretty clever, isn't it?
This is truly fascinating stuff. So we have these incredibly powerful AI systems built with these sophisticated networks trained in different ways. What are the real-world advantages, the benefits that they offer across different industries?
Oh, the benefits are substantial and really far-reaching. One of the most significant is automation.
Automation. Makes sense.
AI can automate a wide range of workflows, processes. It can even operate autonomously without direct human intervention in some cases.
Like what?
Think about AI-powered systems in cybersecurity constantly monitoring network traffic for threats. Or robots in smart factories navigating autonomously, inspecting products for defects.
Hmm.
Digital twins that simulate real-world systems rely heavily on AI. Real-time data analytics for immediate insights, all fueled by AI-driven automation.
That sounds great for efficiency. Automation can certainly drive efficiency and productivity. What's another key advantage of AI?
Another crucial benefit is the potential to significantly reduce human error.
Ah, consistency.
Exactly. By automating tasks and using algorithms that follow consistent, precise processes, AI can eliminate many types of manual mistakes, the kind that are common in data entry, data processing, manufacturing assembly, financial modeling, anywhere accuracy is critical.
And I can imagine that by taking over these error-prone, maybe tedious tasks, AI frees up human workers.
Absolutely. That's another major benefit. AI can take over repetitive tasks.
The boring stuff.
Often, yes.
Right.
Those mundane, tedious jobs that can drain human energy and focus. This frees up human capital people to concentrate on higher impact work.
Like what?
Work that requires creativity, strategic thinking, complex problem-solving interpersonal skills, things humans excel at.
Right.
So AI handles verifying documents, transcribing calls, answering basic customer queries, maybe deploying robots for jobs that are truly dull, dirty, or dangerous.
So it's not just about doing things faster, but also doing them more consistently and letting humans focus on more valuable, engaging activities.
Precisely. Though speed is definitely a factor too. AI is also exceptionally fast and accurate at processing
So
information.
better than us.
Much faster, generally. It can analyze vast amounts of data much more quickly than any human or even team of humans could. And in doing so, it can identify subtle patterns and complex relationships that might otherwise remain hidden.
And unlike us, AI doesn't need coffee breaks or sleep.
That's right. Infinite availability, or at least continuous availability, is another key advantage.
Always on.
When deployed in the cloud, AI and machine learning systems can be always on, continuously working on their tasks, 247, regardless of time constraints or human limitations. That continuous operation can be a game changer.
Finally, the source material highlights the role of AI in advancing research and development. How does that work?
Yes, that remarkable ability of AI to rapidly analyze massive and complex data sets is significantly accelerating the pace of research and development across numerous scientific and technological fields.
Example.
We're seeing this hugely in areas like pharmaceutical research. AI can help predict potential drug candidates, analyze clinical trial data much faster.
Speeding up drug discovery?
Potentially, yes. And in genomics, AI helps quantify and understand the human genome much more rapidly than traditional methods ever could. It just crunches through the data incredibly quickly.
It's clear that AI is rapidly moving beyond just theoretical concepts and into very practical applications across a wide spectrum. Can you give us some more specific examples of how AI is being used in the real world today, just to paint a clearer picture?
Absolutely. We've touched on a few already, but let's list some concrete examples that show the breadth of AI's impact.
Okay.
Speech recognition. Converting spoken language into written text. Many of us use this daily with virtual assistants, dictation software, transcription services.
Very common now.
Image recognition. used in everything from facial recognition security systems to automatically tagging friends in your photos on social media.
Mm,
Translation AI, breaking down language barriers in real time through various apps and online platforms. It's getting remarkably good.
it really is.
Predictive modeling,
Yeah.
helping businesses forecast future demand, optimize inventory levels, assess financial risks, making predictions based on
Okay.
data analytics,
Cool.
using AI algorithms to uncover valuable business intelligence hidden in vast data sets, leading to better, more informed decision-making.
And security.
Yes, cybersecurity. Systems are increasingly using AI to autonomously scan networks for potential threats and anomalies, trying to catch attacks faster. It provides a critical, often automated layer of defense.
It's truly amazing how many different areas are already being transformed by AI. The source material also mentions specific Google Cloud AI products and solutions. Can you give us a glimpse into some real-world implementations of AI on a platform like that?
Sure, Google Cloud, like other major cloud providers, offers a comprehensive suite of tools. They're designed to empower organizations to build, deploy, and scale their own AI algorithms and models.
So, tools for developers.
Yes, primarily.
Hmm.
For instance, Vertex AI is a unified machine learning platform. It aims to streamline the entire process, building, deploying, managing AI models, all in one place.
Okay.
Then there's Vertex AI Studio. That provides a more user-friendly environment specifically for rapidly prototyping and testing generative AI models.
The creative ones like Jan's.
Exactly. The ones that can create new content like images, text, code.
So these are tools for building the AI itself. What about applying AI to address specific business challenges? Are there ready-made solutions?
Yes, there are also more solution-focused offerings. Document AI is a great example. It helps automate the process of extracting data from various types of documents, invoices, receipts, forms,
Taking the pain out of paperwork.
pretty much.
Yeah.
It significantly reduces manual processing costs and errors. Another interesting one is AlloyDB AI. It allows users to build generative AI applications directly using the familiar PostgreSQL database, integrated with Vertex AI.
Bringing AI to the database level.
Kind of, yeah. And for businesses focused on customer interaction, there's Contact Center AI.
For call centers.
Exactly. It offers AI-powered virtual agents that can handle customer inquiries, answer common questions, route calls, improving efficiency and hopefully the customer experience.
Mm-hmm.
And related to that is Dialogflow CX, which provides tools for creating sophisticated, natural-sounding conversational experiences, chatbots, voice assistants across different platforms. These are just a few examples, really, showing how organizations are leveraging the power of AI through cloud platforms to get deeper insights from their data and automate key processes.
This has been an incredibly informative overview. Really helpful. To bring our deep dive to a close, could we summarize some of the key takeaways, the main points our listeners should remember about AI?
Certainly. I think the main thing is that AI is a broad, rapidly evolving field. It's a diverse set of technologies aimed at enabling advanced computational capabilities.
More than just one thing.
Exactly. At its core, AI relies on learning from vast amounts of data through sophisticated algorithms. We've differentiated between the various types, the narrow AI we have today,
AI.
and the hypothetical realms of general and superintelligence, AGI and ASI.
Right.
We also delved into the main training models, supervised, unsupervised reinforcement learning.
How AI learns.
Right. And we examined the powerful architectures of artificial neural networks like feedforward, recurrent RNNs, convolutional CNNs, and those generative adversarial networks, GANNs.
And the potential benefits for businesses and society as a whole seem truly transformative.
Absolutely. AI offers significant advantages. Things like automation, reducing human error, handling repetitive tasks.
Freeing up people.
Yes, plus enhanced speed, continuous availability of systems, and importantly, accelerating research and development, all leading to that multitude of practical applications we see increasingly integrated into our daily lives.
So as we look ahead, what's one final thought you'd like to leave our listeners with regarding this fascinating world of AI? Something to chew on.
Well, maybe consider the potential long-term trajectory. Think about how those different conceptual stages we discussed, reactive limited memory, and then the theoretical possibilities of theory of mind and self-aware AI, how might they ultimately shape our future?
What happens next?
Yeah. What profound shifts and implications that we see as we inevitably progress beyond the narrow AI we have now. And maybe just take a moment to reflect on the AI-powered applications you already encounter in your daily routines.
The ones we use without even thinking.
Exactly. How might those technologies evolve? And Maybe more excitingly, what entirely new possibilities might they unlock in the years to come? It's definitely something worth thinking about.